Okay, this is the P4 paper from January 2021. It's question number 6, which is a differentiation question, and in particular, implicit differentiation. We've got a function there that can only be differentiated implicitly. What have we got to do? We've got to find dy by dx for the first part. That's hopefully relatively straightforward. And then after that, we've got to use dy by dx in context to find the equation of a normal, which again, hopefully we should be able to do. Let's go back and look at our dy by dx then. So part A, my function is 4y squared plus 3x. Shouldn't really have too many difficulties differentiating that part. Is equal to 6y e to the minus 2x, and we're going to need to treat this as a product when we're doing that. Now, if you're not very confident, you can break each bit down separately, but I think I'm just going to go ahead and crack on and do this one. If we're differentiating 4y squared, multiply by the power, take one off the power, so that becomes 8y. Because it's a function involving y, we always have dy by dx on the end of it, plus differential of 3x is just 3, no comments about that at all. Now, differentiating this one, so as I say, you could slow this all down. I'm going to be using u dv by dx plus v du by dx. I know there's a lot of quite confident students out there that want to just be able to do this straight away like that. And so if you do want to be able to do that like that, I'm going to show you this one this time. U dv dx then, well, u is 6y, dv dx is just a differential of e to the minus 2x. Differential of e to the minus 2x, at this stage you should be pretty confident at just being able to jump straight in with that, is minus 2 e to the minus 2x. That's u dv, plus v du, well, v is e to the minus 2x, and du is a differential of 6y, and the differential of 6y is 6 dy by dx. The reason I do it quite quickly is we've got lots of other steps to do here, and if you're spending ages trying to sort all this out in terms of your layout and everything, it can just get a bit confusing. So if you are confident, just go straight into that. Now what we've got to do is to tidy this all up, and then once we've tidied it up, get dy by dx equals. So I've got here 8y dy dx plus 3 is equal to minus 12y e to the minus 2x plus 6e to the minus 2x dy by dx. Get all the dy by dx's on one side and get all the other values onto the other side. In this case, that's going over there and that's going over there. So if I'm going to do that, I'm going to get 8y dy by dx minus 6e to the minus 2x dy dx is equal to minus 12y e to the minus 2x minus 3. Now, there's nothing to stop me actually doing that the other way around to get rid of the minuses, but I'm going to leave it like this just so you can see. It doesn't matter which way round you sort this all out, we can tidy it up at the end. Take dy by dx out as a factor. Is going to give me 8y, my goodness sake, Mr. Peter, slow down. Is going to give me 8y minus 6e to the minus 2x is equal to minus 12y e to the minus 2x minus 3. So then divide that out, dy by dx is now going to be equal to minus 12y e to the minus 2x minus 3 all over 8y minus 6e to the minus 2x. Now you can absolutely tidy this up if you want to. If you took a minus out, for example, on that top, you'd have 12y e to the minus 2x plus 3, and at the same time take the minus out of the bottom, you'd have 6e to the minus 2x minus 8y. Both of them the same, both of them are absolutely fine. There's no reason why you can't use one or the other one here. What you can also do is start factorizing, because 3 comes out the top part and 2 comes out the bottom part. But I don't need to do any of that because they didn't in the question ask me to show it was equal to something. Personally, I think it would have been a better question if they had said show it's equal to. All I was asked to do was get dy by dx. So I've got that. And then after that, I'm going to be using it in part B. That's the only reason, actually, that I changed this business round, was because actually substituting in, I just think I'm less likely to make a mistake with the dy by dx I've got there. What does part B actually say? It says find the equation of the normal at a particular point. Okay, so if I want to find the equation of the normal at a point, what I need is x1, y1, and m. Remember, my equation of a normal, equation of a tangent, they're both the same because they're an equation of a straight line. So yeah, in this case, I'm going to say equation of a normal. Y minus y1 equals m x minus x1. What I've got to do is to work out m, which is the gradient. For the normal, it's minus 1 over the gradient. I need to find x1 and I need to find y1. Let's go back and look at the question. So it says the curve crosses the y-axis at the origin and at the point P. So it's where it crosses the y-axis. If it's where it crosses the y-axis, then we know x is equal to 0. So for P, x is going to be equal to 0, and what I need to do is to work out what y is. So if x is equal to 0, let's put that into the original equation. So putting that into the original equation, I'm going to get 4y squared plus 0, x is equal to 0, is equal to 6ye to the 0. Okay, I'm going to get 4y squared is equal to 6y. Let's solve this. I'm going to get 4y squared minus 6y equals 0. Take 2y out as a factor there. I'm going to get 2y minus 3 equals 0. So I'm going to get y equals 0 or y equals 3 over 2. Let's just explain what we're doing there. It says the curve crosses the y-axis at the origin and at the point P. Well, the origin is given by that information there, x equals 0, y equals 0, and the point P now is given by that information. So we know P is 0, 3 over 2. So I have my x1 and my y1 here. What I still don't have is m. Be careful with this bit. So I'm going to actually make this clear to the examiner as well. For the gradient of the tangent, not the gradient of the normal, for the gradient of the tangent, dy by dx will be equal to my function for dy by dx, which was that, or whatever version of that you got when you did it, but I need to put in the points 0, 3 over 2. So equals that. So at 0, 3 over 2, this is going to be 12 lots of 3 over 2 e to the 0 plus 3. 6 e to the 0 minus 8 lots of 3 over 2. Remember, e to the 0 is just 1. So that's going to really simplify down. I'm not going to spend any more time on that. You can just work that out. It works out to be 21 over minus 6, or in other words, minus 7 over 2. But that's the gradient of the tangent. So the gradient of the normal is minus 1 over that. So lots of little places where we might make mistakes here, where we really need to focus on what we're doing, take our time over it. So I've now got everything that I wanted in this information here. In fact, I'm going to write that out again. I'm going to say y minus y1 equals m x minus x1, and I'm actually going to tell the examiner x1 was 0, y1 was 3 over 2, and my m here was 2 over 7. So even if I've made any mistakes, this examiner can perhaps give me some method marks by seeing what I'm actually doing. And I'm less likely to make a mistake with this last part now if I write it all down like that quite clearly. Give me a time to just stop, check everything, go back, just make sure you're happy with everything before you go on and finish this question off. So y minus y1, y minus 3 over 2 is equal to 2/7 x minus 0. Let's just go back. Did it say anything about how? Well, yeah, in the form y equals mx plus c. Okay, so if it's in that format, then when we've got it down like that, we're going to get y minus 3 over 2 equals 2 over 7x. So y actually equals 2 over 7x plus 3 over 2. And again, for this question, it would have been quite nice if at some stage through it, they said show that, would have made me feel a bit more confident, but there's a 9-mark question on implicit differentiation. Hopefully all that makes sense.